This is section 6.1, and this whole unit is all about parabolas. Now, you've probably done a little bit with parabolas last year, or I'm sorry, not last year, but back in Algebra 1. But this year, we're going to do a lot more with the concept of parabolas. Really, for the whole rest of the semester, it'll come up quite a bit. Okay, so if you were to, let's just kind of start basic. If you were to look at these equations on your calculator, and today I'm showing you, I'm developing this lesson on the calculator, but the whole idea is that we're going to kind of notice the things that these equations have in common so that for the entire Unit 6, you won't have to use your calculator. So this is just a kind of a teaching method, so you don't even need to get out your calculator. This is just to kind of show you. So if I were to graph that first equation, y equals x squared, and I'll go ahead and put in number 2 just so I have it ready. The x squared plus 2. Okay, I'll turn that off so that doesn't actually graph. And so I'm just going to graph that first equation, y equals x squared, and you may or may not remember, but it's going to look something like this. So the things to notice are that the vertex, in other words, that turning point is right there at the origin. And this isn't going to be exact, but if I were to graph it, it would be something like this shape. And for now, we're just trying to get the basic shape. Okay, if I were to put the next equation in, I've already got that one in. So there's my y equals, and I think I'll just go ahead and leave that one, and I'll turn this one back on. So this one's going to be red. So the red is the one that we're actually looking at. And if I were to add that one, you'll notice it's the same basic shape, except it's moved up a little bit. Now, it actually looks a little bit smaller, but that's just because it's moved up. If we were to move our graph up higher, it would look like the exact same shape, but notice this time the vertex is like right here, something like that. And let's see, I could put in the next one, which was, well, I'm going to go down to number 4. So for number 4, I'll just clear these out. I'll put in that next one, which is 0.25x squared minus x minus 3. So it's another version. It has an x squared, but it has, other numbers. If I were to graph that one, okay, that's still kind of the same shape. It's a little bit, it's kind of moved over and down, and it looks a little bit wider. So again, this is just going to be kind of a rough estimate. Let's see, it looks like it goes through 2 on the x-axis and 6 on the x-axis, just so I can kind of make it look similar-ish. So it was something like this. Again, I'm not saying that's exact. If I were to look at number 5, the 3x squared plus 4x minus 1. So let's see, 3x squared plus 4x minus 1. What does this one look like? Okay, it's a little bit skinnier. It's kind of moved the other direction, but it's still the same basic shape. Again, it's just a different version of that same shape. So again, this isn't exact, something like this, right? A little skinnier version. And number 6, if I were to put in negative x squared, let's see what that looks like. So negative x squared, if I were to graph that one. Okay, so it's the same basic shape. It's just kind of flipped over, opening down. So negative x squared does something like this. Okay, so the point here, and I know I didn't graph number 3, but it doesn't matter. This is enough to kind of show you. So the graph of any quadratic equation, and quadratic equation means it has x squared in it. Now, I realized if these equations had other numbers, but they all had an x squared. That's the one thing that they all had in common. So the graph of any quadratic equation will look like the shape shown below. So remember, some of them were opening up, some of them were opening down, some of them were more wide, some of them were much more narrow, but they're all the same basic shape, okay? And that's the shape that we call a parabola. Okay, so this unit is all about parabolas and graphing parabolas. Okay, so our parent function in vertex form, so the quadratic parent function is simply y equals x squared. That means it's the most basic form of a parabola. So the quadratic parent function goes through the origin right here, it has another point that's kind of an up 1 over 1 on each side, and it's approximately this basic shape. Okay, so that's the general shape of a parabola. Now, when we talk about vertex form, we're going to say, well, you might have, when you have this equation, you might have some number out in front. For now, I'm just going to call it A. So there might be some number right there where the A is. And then you could have X, and it could be plus or minus some particular number. And again, it doesn't matter what I call this number. I'll call it H, just because a lot of textbooks tend to call it that. But that H is not significant. It just means wherever I'm putting these pink letters, those are where numbers might be, okay? And it has to be squared, because that's what gives us this x squared concept. And then out at the end, you could add or subtract any particular number, and I'm going to call it k. So again, the A, the H, and the k, those are just places where you could have different numbers. And those different numbers will change the shape of this basic parent function. Okay, so let's talk about what those numbers do. So I could put these in my calculator, but I already know what they're going to do. So I'm going to show you what the calculator would do. All right, so if I put in the basic quadratic, I'm just going to color code here. That's the x squared. Remember, it goes through the origin, has a point here and here, up 1 over 1. And so the basic shape, oops, I've got to kind of get in the mode of graphing here. So the basic shape of this parabola is something like that. Wish I could draw it better with this pen. Sorry about that. There's the basic shape of my parabola. Okay, if I were to put a +2 out at the end, and you notice that +2 is right here at the end, any number being added or subtracted at the end, what that +2 is going to do, it's going to move the entire thing up 2 units. So instead of having the vertex down there at the origin, it's up there at 2. I still have this up 1 over 1 point, just like these, but the entire graph is moved up 2 units. If I were to, instead of having a +2, if I were to have a -2, that means the whole thing is moved down 2. So it's down here. Again, it still has the up 1 over 1 to give it the exact same shape, but it's just moved down 2 units. So that just shows you that k out there at the end is going to move your entire parabola up. I'm going to say here, shift up or down. Shift the entire parabola up or down. Okay? Well, what if there's a number added or subtracted on the inside? Okay, so do you see right here where the H is? What if there's a number added or subtracted inside that parenthesis? So that's what I'm talking about by this next section. So let's put on the basic parabola. Remember the basic parabola, the parent function goes through the origin. It has the up 1 over 1. So there's my basic parabola. Okay, if I have that plus or minus 2 right here on the inside, if it's a +2, it's actually going to shift it this direction. Okay, I'm still going to have the up 1 over 1 point. It's still going to be going this direction and be the same basic shape. It's just that notice it's shifted to the left. I know that seems strange because over here is where the x's are negative. Over here is where the x's are positive. So in a lot of ways, I would look at this as being the opposite of what you would think, right? If it's a +2, it actually goes to the left. If it's a -2 on the inside, it's actually going to be shifted to the right. I guess I should color code that one. Say -2, it's going to go to the right. So from the origin, it's going to go to the right too. Again, still have the up 1 over 1. So it's going to be this basic shape. So hopefully all of those parabolas look like the exact same shape. They're just shifted either to the left or to the right. So let's come up here and let's say, okay, where the H is, the number on the inside is going to shift either to the left or to the right. And it might help if we do this. It shifts to the left if it's a plus. It shifts to the right if it's a minus. Okay, now there's one last place where you could have a number, and that's out here in front. Notice it's not being added or subtracted, it's being multiplied out there in front. And we'll talk through that in a minute. But let's kind of come down here to this box. Okay, this is kind of our summary. So notice every single one of these starts with the basic parent function of just x squared. I know you're like, well, where's the x squared? Well, the x squared is right there. And right here is your x squared. Okay, so the first thing we talked about is if you add or subtract a number, C stands for constant, any number at the end, +2, -7. Okay, add or subtract at the end, that is going to shift up or down, right? If it's a plus, it shifts up. If it's a minus, it shifts down. The next thing we talked about is if you add or subtract on the inside, we said that's going to shift either to the left or to the right. Again, the left is if it's a plus, the minus is to the right. Now, I know we haven't talked about the number out in front, but let's just kind of look at number 1 down here, okay? So notice you've got the -3 out at the end. That -3 means the whole thing is going to go down 3. And then you have the +2 on the inside. That means the whole thing is going to go to the left 2. So the basic parabola starts right here at the origin. So from that point, I'm going to shift 2 to the left and at the same time 3 down. Okay, so no longer is it right here at the origin. It still has the up 1 over 1 because it's still the exact same shape. It's just shifted left and down. So there is the parabola. It's shifted left and down. Okay, go to number 3. We can't do number 2 yet because we haven't talked about what that negative does. Go to number 3. In this case, you've got the +1 at the end, so that means the whole thing is going to be shifted up. You've got the -2 on the inside. That means the whole thing is going to be shifted to the right. So again, from the origin, that's where the basic parabola starts. We're going to shift to the right 2 and at the same time up 1. So that means the new vertex is over here. You still have the up 1 over 1 point. So the entire parabola is just shifted to the right and up. Okay, so that's just a little bit of practice of moving it up or down and shifting it left or right. Okay, let's go back to what we were talking about a minute ago here. What if you have a number out in front of the parabola? Well, here's my basic parent function, right here. This is my basic parent function that's at the origin. It has the up 1 over 1 point, so something like this. Okay, now notice the number in front of the x squared is actually a 1. That's why that point, those other 2 points we have are up 1 over 1 because of that 1. If I have a 3 out in front, so the vertex is still at the origin because the whole thing has not been shifted up or down or left or right. But that 3, it changes where I put the next points. Now, I'm going to put this word in print or in quotes. Whoops. Hopefully I'll spell it right. Slope. Because it's not really the slope because parabolas, the slope changes, where you are in the parabola, but it's the idea of slope. Remember when we were graphing lines, slope was the up and over number, like the change in y over change in x. So on number 1, where you went up 1 over 1, we're going to think of our slope as being 3 over 1. So from that vertex, we're going to go up 3 and over 1. And then you just naturally do it on both sides. I get that really on the other side, you would think of that as a slope of -3. But again, it's not really the slope. It's more about the slope telling me about how steep the sides of the parabola are. Okay, so if I were to draw this parabola, it's going to do something like this. So basically, it's going to make that parabola look a little more narrow because it's making the sides a little bit steeper. Okay, now the next one, the number out in front is 1/3. Now here's where you really have to understand that that's not really the slope, because even though my vertex is still here at the origin, I'm not going to go up 1 over 3. That's how you do it if it's a line, but that's not what this is. the slope on a parabola only works if you're 1 unit away from the vertex. So instead of thinking of this slope as being up 1 over 3, you have to think of it as like 1/3 over 1. So from that vertex, and I'm going to get rid of these I guess just so you can see this one a little better. I'll at least get rid of the pink one. So from that vertex, I'm going to go up 1/3, so just a little bit, and then over 1. Do you see how that point might be like up 1/3 over 1, up 1/3 over 1 on this side? And so what that's going to do is it's going to make this parabola actually look much wider, okay? So something to kind of keep in mind is if that number out in front is a fraction, it's going to make the parabola look wide. If that number out in front is more than 1, okay, so that if that A number that's out in front, remember the A number is out in front, if that A number is greater than 1, so like if it's 2, 3, 5, that's going to actually make your parabola look more narrow. Okay. Well, what if that number in front is negative? Well, again, you use that concept of slope. So let's put on our basic parabola, right there at the vertex, up 1 over 1. There's my basic parabola. All right, I just cannot graph with this pen. There's my basic parabola. So if my slope, again, I wish you could see me because I'm using air quotes. Let's do that. Okay. If my slope is -3, that means instead of going up 3 and over 1, we're going to go down 3 and over 1. So that is what's going to make your parabola. So the vertex is still at 0, 0, but having a negative out in front is going to make your parabola open down. So the 3 makes it be kind of narrow. The negative makes it open down. Okay, so down here for number 3 is all about if you have a number out in front. So I'm going to use the idea of slope. Make sure you put in quotes because I don't want anyone to think that that really is a slope. But what's significant here is if that number out in front is negative, that's what makes the parabola open down. It's not shifted down, it opens down. Okay, so let's come back to our examples and look at number 2. So for my parabola, because of the negative, I know it's opening down. Let's put here open down. That doesn't mean it's shifted down. That means it opens down. And then notice this +2 is out at the end. It's not in a parenthesis. So the entire parabola is moved up 2. But because it opens down and the number in front is just like a 1, right? There's like a 1 right here. So from there, I'm going to go down 1 and over 1. So this parabola is going to look something like that. Okay, let's look at number 4. All right, well, I see a couple things going on here. I'll take care of the negative at the end, right? I know that negative means the whole thing is going to open down, right? But keep in mind, this +2 over here is going to move the whole thing to the left. Nope, I'm sorry. It's going to move the whole thing up. It means it's not opening up. That means it's shifted up. And that +1 is going to move the whole thing to the left. So let's do the +1 and the +2 first. So I'm going to go to the left one, and at the same time, I'm going to go up 2. That's my new vertex. And now I apply that slope concept. So from that point, I'm going to go down 1 and over 1 on each side. So there is my basic parabola. Okay, look at number 4. In this case, there is no parenthesis. So if there is no parenthesis, the whole thing's not shifted left or right. But because of the -3, I know it's going to shift down. So the vertex is shifted down 3. But notice that slope number is 2. So from the vertex, I'm up 2 over 1. So this parabola is going to look a little bit more narrow than the last one. But it still is opening up. Okay, now number 6, it has a number on the inside, so it's going to be shifted to the right, but notice there's no number out at the end, so it doesn't shift up or down. So this one is shifted 2 units to the right, and then because that slope number is -1, I'm going to go down 1 and over 1. So there's my basic parabola. Okay. So look at number 7. I always do the shifting part first. I always shift it first, and then I use that slope number to determine how wide or how narrow it's going to be. All right, so I'm going to go 2 units to the right, and at the same time, 1 unit down. So 2 to the right, 1 down. That's my vertex. So something to keep in mind is the H number and the K number are the ones that determine your vertex. Right? That's what moves it left, right, or up, down. Okay, now from that point, since my slope number is -1/2, and remember how we said you have to think of that as being like over 1. So I'm going to go down 1/2 and over 1, down 1/2 and over 1. And then I like to exaggerate it a little bit because remember, if it's a fraction, it's going to make it look a little bit wider. So I want to make sure that this parabola looks wider. Otherwise, you're going to think all parabolas look the same. That's kind of pointed. Sorry about that. I just can't draw with this pen for some reason. Okay, that's the best I can do. Sorry. Okay. And then on number 8, so I've got 2 down and 3 to the left. So that's what I always do first. So 3 left, 2 down. There's my new vertex. And then from that point, I'm going to use that slope idea. So up 4 over 1. So this one's going to be a pretty narrow parabola. Okay. And then the last one, number 9. Notice there's no parenthesis. That means it's not shifted left or right. So this one is just moved up 2. And then because of that 1/4 out in front, I'm going to go up 1/4 and over 1. So I'm just going up a teeny tiny bit and over 1, which means this parabola is actually going to be pretty wide. Let's see if I can do this side. Okay, so that parabola should look pretty wide. Okay. So look here. What if we go the other direction? What if I give you the parabola and I want you to write the equation? Well, something that might help us is I'm going to put this here. I'm going to say y equals, remember vertex form, you might have a number in front. Then you have x either plus or minus, depending, some number, I'll call it h, right? That's being squared. And then at the end, you're adding or subtracting some number I'm going to call k. So remember, I have to consider, should there be a number out here in front where the a is? Should there be a number right here for the h? And should there be a number right here for the k? Okay, so when I look at number 1, I'm going to say y equals, it's opening up, so I know it's positive out in front. Even though the specific points aren't drawn in, you can see that there's a point here that's like an up 1 over 1. So that means the a is 1. Now, when a is 1, you don't really have to write it. I'm only going to write it to show that I remembered to think about it. Okay? And so the inside is always going to be x. And now, because this is moved 2 units to the right, because it's moved 2 units to the right, that means the inside's going to have a -2. And notice this one's not moving up or down. So there's no number out in front, right? It's kind of like a +0. You don't have to write +0. I just wanted you to see on this one that I have taken into account the a, the h, and the k. Those are the 3 things you have to consider when you're writing the equation. Okay, so look at number 2. I'm going to say y equals, I know it's a positive out in front because it's opening up. I can tell the slope idea, it was an up 1 over 1, so there's kind of like a 1 out in front. Okay, this one was moved 2 units to the left, so it's going to be x plus 2. And it was also moved 3 units down, so that's why it's a -3 out there. Now, don't forget, you always have to have that square on the parenthesis because that's what makes it be a parabola. Without that square, it's just the graph of a line. Okay, so let's look at number 3. So it's y equals, I'm going to go ahead and put a negative because of the fact that it's opening down. Notice in this case, you can tell that the slope is down 1, 2, 3, and over 1. So that's why it's a -3. Now, there's my parenthesis squared. In this case, it's not moving left or right, so there's not really an h number. It's kind of like an x plus 0. Again, you don't have to write the +0. If you want, you could have just said x squared. If there's not a parenthesis, you don't have to write it. And then out at the end, because this whole thing was moved up 2, I need a +2. Okay, so once you've done this a little bit, you'll probably go straight to saying -3x squared whoops, I don't know what changed me to a pink there. Negative 3x squared plus 2. Same thing. Okay. Number 4, I'm going to say y equals. Now in this case, can you tell that that point is only up like a half? So I'm going to say 1/2. And then because it's moved 3 to the right, I'm going to say x minus 3. And then it's moved up 1. Okay, look at number 5. Y equals, I know it's a negative because it's opening down. It looks like it's about a 1/2. Doesn't look like it's down 1/2 and over 1 to get to that point. So I'm going to say negative 1/2. Okay, is it moved left or right? Yeah, it's moved 2 to the left. So x plus 2. And in this case, it's not moved up or down, so I don't need anything out at the end. All right, number 6. Again, just because you don't see the points drawn in doesn't mean that they're not there. I mean, I can tell the vertex is right here. I can tell the whole thing's opening up. Now, was this an up 1 over 1? If it were an up 1 over 1, then I would have points here. That's clearly not what's going on. Doesn't it look like it was an up 2 over 2? Again, just because they're not drawn in for you, you can still tell where those points are. So I'm going to put a 2 out in front. And then because it's moved 3 to the right, I'm going to say minus 3. And then the whole thing was moved down 4, so minus 4. Okay, so that's kind of vertex form of a parabola. And we, kind of did both directions. You drew the whole graph, and then you look at the graph and write the equation. And you'll notice in the homework, you've got the same concept, right? You got a couple pages of, hey, you do the whole graph. And then there's a page of, hey, here's some graphs. And now you write the equation.